Have you ever tried to really, truly wrap your head around the universe? It's basically impossible. But today, we're going to give it a shot. We're going on a journey to measure the cosmos, figure out what it's actually made of, and see where we fit into its absolutely epic timeline. So let's start with a little perspective check, right here in our own neighborhood.
Okay, think about the moon. It feels pretty close, right? You can look up and see it almost every night. But that space between us and our lunar buddy, it is huge. So huge, in fact, that you could take Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune and line them all up side by side right in that gap. And get this, even after you've parked all 7 of those planets between the Earth and the Moon, you would still have over 8,000 kilometers of empty space left over. That's almost enough room to squeeze in another planet the size of Earth. It just goes to show you how much of space is just, well, space, even right next door.
All right, so we've got a sense of scale for our own little cosmic corner. Now it's time to take a giant leap. We're about to zoom way, way out, past our galaxy, and into the truly mind-boggling depths of the universe.
First stop, our home, the Milky Way galaxy. This number, 100,000 light-years, is how wide it is. That means it would take a beam of light, the fastest thing in the universe, a full 100,000 years to get from one side to the other. Our entire solar system is just a tiny, tiny speck in this enormous city of stars.
So what's next door? Well, our closest major galactic neighbor is Andromeda, and it's 2.5 million light-years away. That gap between us is this vast, dark, almost unimaginable emptiness. It really drives home that galaxies are like these lonely, beautiful islands floating in a colossal cosmic ocean. But here's the thing. Galaxies aren't just sprinkled randomly. They actually clump together, forming these gigantic structures. This number, 500 million light-years, is the kind of length we're talking about for things like the Great Wall, a massive chain of galaxies all linked by gravity. We're not just looking at stars anymore. We're looking at the grand architecture of the universe itself. And here we are, the last stop, 93 billion light-years. That's the diameter of the observable universe. It's a number so big our brains can't really process it. It's the absolute edge of everything we can possibly see, a boundary created by the speed of light and the age of the universe. It's the whole shebang.
So we've just traveled across 93 billion light-years. We've seen how impossibly big everything is. But that just raises an even deeper question. We see all these stars and galaxies, but what is the universe actually made of? Let me tell you, the answer is way, way weirder than you think.
So let's do it. Let's take that entire 93 billion light-year sphere and break it down. All the matter, all the energy, everything. What are the ingredients in the universe's recipe?
Let's start with what we know. Every star, every planet, every galaxy we've ever taken a picture of, every person, every grain of sand, every single atom you can think of, all of it, adds up to this tiny little sliver, just 5% of the whole pie. So the million-dollar question is, what in the world is the other 95%?
Well, here it is, the complete picture. And it turns out most of the universe is made of 2 things we can't see and barely understand. About 27% is something called dark matter, which is like the invisible skeleton that holds galaxies together. And a whopping 68% is dark energy, this mysterious force that's actually making the universe expand faster and faster.
So what's the job description for each of these things? Well, dark energy is the engine, pushing everything apart. Dark matter is the glue, providing the gravity that keeps galaxies from flying to pieces. And ordinary matter? Well, that's us, and everything we've ever seen. We're basically the cosmic afterthought, the interesting little bit of decoration on top.
Now, even though that ordinary matter slice is tiny, it's where some of the most extreme, most unbelievable objects in the cosmos are hiding. So let's meet a couple of the universe's record holders for being absurdly big and ridiculously dense. So on one end of the spectrum, you have the neutron star. This is all about density. Imagine taking something 1.5 times heavier than our sun and crushing it down until it fits into an area the size of a city. Then on the other end, you have pure mass, supermassive black holes that can weigh up to an incredible 66 billion times more than our sun. See, a neutron star is called the densest form of observable matter. That word observable is so important. It means it's the densest stuff we can actually see and study, matter that's been squeezed right to the very edge of collapsing into a black hole. Just one single teaspoon of a neutron star would weigh billions of tons here on Earth. Just mind-blowing.
Okay, so we've tackled the universe in terms of space, and we've talked about what it's made of. For our last big perspective shift, we're going to look at it all through the lens of time, all 13.8 billion years of it.
How do you even start to comprehend a timeline that long? Well, there's a really cool analogy called the cosmic calendar. The idea is simple. You take the entire 13.8 billion year history of the universe and you squish it down into a single 365-day year. On this calendar, the Big Bang happens right at midnight on January 1st. Our own Milky Way galaxy doesn't even start to form until sometime in May. Our solar system? It's a latecomer, not showing up until September 9th. And what about us? Humanity? All of our recorded history. Every king, every war, every invention, every song, all of it happens in the last 2 seconds before midnight on December 31st.
So here we are, living in a tiny fraction of a cosmic second on a tiny planet made of the rarest stuff in the universe in one galaxy among trillions. When you really take a step back and look at the sheer scale of it all, it just leaves you with one final humbling question. What happens in the next second of the cosmic year?